All right, this is the 2018 AMC 10A problem number 6. Songho uploaded a video to a website where viewers can vote that they like or dislike a video. Speaking of which, you can like this video. Each video, if you want, each video begins with a score of 0 and the score increases by 1 for each like vote and decreases by 1 for each dislike vote. At one point, Songho saw that his video had a score of 90 and that 65% of the votes cast on his video were like votes. Okay, so if you think about this, it says how many votes had been cast on Songho's video at that point. If 65% are like, that means 35% are dislike. And every dislike vote is going to cancel out a like vote. So this 90 is equal to 30% of total votes. Well, then 10% would simply equal 30, which makes 100% 300. Continuing on with the 2018 10A, problem number 7. For how many, not necessarily positive, they didn't have to put this by the way, but they're helping you out, integer values of n is the value of 4,000 times this expression an integer. In order to figure that out, you're going to want to prime factor the 4,000 because the denominator is going to have to divide into it since it won't go into 2, and neither will 2 go into 5 when n is negative. So 4,000 is 4 times 1,000. This is 2 to the third times 5 to the third, and this is 2 squared. So it's 2 to the fifth times 5 to the third times 2 over 5 to the n. Now, we have 3 powers of 5, so n can go up to 3. And if I do negative values, n can go up to negative 5 because that would make 2 to the fifth down here cancel with that. So it's all the way from negative 5 to positive 3. Don't forget 0. You can just do b minus a plus 1. 3 minus negative 5 is 8 plus 1 is 9. Okay, and now the 2018 10A problem number 8. Joe has a collection of 23 coins consisting of 5-cent coins, 10-cent coins, and 25-cent coins. He has 3 more 10-cent and 5-cent, so you're going to let x equal 5 cent, x plus 3 equal 10 cent, and goes on. And the total value of his collection is 320 cents. How many more 25-cent coins does Joe have than 5-cent coins? So we can make 25 cent as equal to 23 minus these 2. This is a pretty standard algebra problem. So 23 minus 2x plus 3 is going to be equal to 20 minus 2x. So now we can say it's 5x plus 10 times x plus 3 plus 25 times 20 minus 2x needs to equal 320. So we get 10x and 5x is 15x, minus 50x is negative 35x. I've got 30 plus 25 times 20, which is going to be 500, plus the 30 is equal to 320. So 530 minus 320 is 210 equals 35x, and x will equal 6. Okay, so now if there's 6 5-cent coins, there will be how many 25 cent? 20 minus 12 is 8. So 8 compared to 6, he has 2 more 25-cent coins. Okay, and now for the 2018 AMC 10A problem number 9. All of the triangles in the diagram below are similar to isosceles triangle ABC, in which AB equals AC. Each of the 7 smallest triangles has area 1, and triangle ABC has area 40. What is the area of trapezoid DBCE? The best tool for this problem is your similarity concept for shapes and solids. And this should be in every student's tool belt. For similarity, all lengths will be a to b. All areas will be a squared to b squared. And if there were volumes, they would be a cubed to b cubed. We don't have to worry about volumes because we're in 2 dimensions, but you should think of all of them at the same time. How do we know to pull this out? Because it says they're all similar. So we're going to start with, this has an area of 1 where the whole thing has an area of 40. That's an area ratio. We're going to square root to get to a length ratio of 1 to 2 root 10. Okay, so then we can consider that the length of this small triangle is 1 unit. Whatever, it can be 2.57 centimeters, can be 1 unit, it doesn't matter. And this will be the corresponding 2 root 10 units. All right, then DE going across this way is now 4 units, and we're back to a length ratio of 4 to 2 root 10. You simply square this to get back to areas, 16 to 40, and that means the upper triangle is 16, and the bottom trapezoid is the difference of 40 and 16, which is 24. All right, and now for the 2018 10A problem number 10. This problem has a significant shortcut if you can perceive it. Suppose that real number x satisfies the square root of 49 minus x squared minus the square root of 25 minus x squared equals 3. What is the value of the square root of 49x squared plus the square root of 25 minus x squared? The trick on this one is you need to think slightly more abstract and not look at this and this, but think of it like a minus b equals 3, right? Let a equal this and b equal that. Why? Because this is a plus b. When we see a minus b and a plus b, that makes us think of difference of squares. So perhaps we can just multiply this by a plus b on both sides, and you will get a squared minus b squared equals 3 times a plus b. Now, a being a square root and b being a square root, we can just square them and get what's inside. 49 minus x squared minus the quantity 25 minus x squared equals 3 times, I'm going to keep it as a plus b. So then the 49 minus 25 is 24. The x squareds will cancel. I can divide by 3 to get 8 equals a plus b, which is what we're looking for. And 8 is answer A.